Hi, Lakers. This video is to help you understand what it means to find boundary values of certain measurements. What I first want you to think about is how accurate are these measurements? This is the distance from the moon to the earth, or earth to the moon. In kilometers, it's 384,400. In miles, it's 293,000 miles. Of course, these are estimates or approximations. These aren't exact distances. This distance changes every second of the day as we rotate in space. But the accuracy is bound by certain values. So, looking more closely at what our textbook resource says, it all depends on what measurement you're using. One is in kilometers. That's rounded to the fourth or to the 100th place. But the miles is rounded to the thousands. So you could say that the kilometers is more accurate because it is rounded to a smaller number. But it really does depend on the units used. And the smaller the measuring unit, usually the greatest accuracy. So if we used, say, meters and feet or yards compared to miles and kilometers, that would give us more accuracy. But let's be specific about bounds. We have this idea of a lower bound and an upper bound to give us an interval of accuracy. The textbook says the lower bound is half a unit below the measure. The upper is half a unit above. So let's put this information into our notebook. If you are working within your table of contents, go ahead and add that title to your notebook. Okay, so what we want just to add is a little bit of notice. So bounds, what we do is take half of the unit measure. That's the first step. So whatever the unit is, multiply it by a half. Then to get the lower bound, we take the measure and subtract half the unit. And then similarly, to get the upper bound, you take the measure and add half a unit. So when we think about 293,000 miles, so in this example, 1/2 of the unit is really 1/2 of 1 mile, which is just a half a mile. Because 293,000 is rounded to the nearest mile. That 0 tells us that that is the final number, the lowest unit, and that is in the ones place. And so we take that ones place, which is 1 mile, and find half of it. And then the lower bound is equal to 293,000 subtract 0.5. So that's equal to 292,999.5 miles. And then the upper, that's usually the easiest one. We're just going to add half a mile, and we get 293,000.5 miles. And then notice the notation. Using interval notation, we would have less than or equals around the 293,000. Lower bound over here, 292,999.5. And then the upper 293,000.5 miles. And that would represent the bounds for 293,000 miles. But what if we had an example like this, where we had to find the perimeter of a rectangular garden? So I'm going to call this example 6 from our textbook. And so we have a rectangular garden. And the measurements are 172 meters by 64 meters. Well, we know the perimeter is just adding up all the distances around. So let's call this 172 meters. Just drawing a small diagram to represent the information. We can add up all those distances and find the perimeter. But what we need to do is find the bounds of our measurements. Excuse me. So first, it's rounded to the nearest meter. So 1/2 a unit is equal to 1/2 a meter. So for the lower bounds, let's start with 172. Well, we would just have 172 subtract 1/2 a meter. And so 171.5 meters. And then using 64, subtracting 1/2, we'd end up with 63.5 meters. Upper bound, we will just add 172 plus that 1/2 meter, 172.5. And then 64 plus 1/2, 64.5 meters. So then when we find that calculation, perimeter, 2 times the length plus 2 times that width, we would have 2 different representations using the lower two times that 171.5 plus 2 times 63.5. I'm going to slide up my notebook and show that calculation. 2 times 171.5 plus 2 times 63.5, and we get 470 meters. And then looking at the upper, we would take 2 times 172.5 plus 2 times the 64.5. And get 474 meters. And so when we create the upper and lower bounds, we would say 470 meters is less than or equal to the perimeter if we use the original perimeter, and that's less than or equal to 474, which would be the upper bounds. So the last thing that we're going to do, and it could have been the first thing we did, was find the actual perimeter using the measures we were given. 2 times 172 plus 2 times 64. And we get 472. And you can see that that is directly in the middle of 470 and 474. I'm going to zoom out so you can see the full picture of my notebook. Make sure that you are recording this in your notebook. And make sure, if you need more practice, to look at the PDF. There's an additional example, finding upper and lower bounds using time. And I have also put some problems from our textbook that apply the idea of bounds. And the solutions are on the final slide of the PDF. Thank you for watching this video.